So this week, we're working on basic units of measurements. And there's a few activities to do with this and a little practice. Basic units we're going to play with are length. Units of length that we're going to play with are mostly going to be meters. Some centimeters are kind of nice, possibly millimeters. Compared to other units we use like feet and inches. Maybe even miles or kilometers, but we're going to stick with some smaller ones for now. We've got mass or weight, which are related, but not exactly the same thing. Mass, we're going to either use grams or kilograms, although sometimes we use non-standard units like ounces and pounds. And then we've got liquid, volume. And so for that, we're mostly going to use liters, but we'll relate back to some ideas about length and volume and how they're related. And then non-standard relation to, say, liters would be quarts. Instead of quarts, sometimes we use cups or liquid ounces, which are a bit different than weight ounces. They're not the same thing. Smaller units than liters would be, say, milliliters that we might play around with. And then temperature. And standard around the world for temperature is Celsius. But we in the United States tend to use Fahrenheit, which is not standard around the world. So we'll take a look at those two today. Important thing this week isn't about conversions, it's about just doing and using certain units. So I'm going to turn off the share and show some of my mess here. Okay. So as far as length goes, in order to play this week, you need something like a ruler. So here I have a small ruler. We zoom in there, you can see I've got, it's kind of hard to read, centimeters at the top, inches on the bottom. A lot of rulers these days will have both. Sometimes a ruler might have inches on one side and centimeters on the other. A tape measure is not a bad thing to have. Here I have a lovely tape measure with a little retract button. This could be yours if you win the Metric Olympics. And sometimes tapes are more flexible, like this cloth one I have here. And I have one at home without a case like we do sewing projects with. So you're going to have to look around your area, your vicinity, your clan. You might have to reach out to friends. You're going to have to find at least one measuring device to play this week. Now, we're measuring different things, right? So that was length there. Then we have mass. Now the mass thing's a little tricky. You got to find a scale. So I have a scale at home we weigh ourselves with, stand on it, right? And I got something like that here. So over here, I got this digital scale I borrowed from a friend, and it's got a little leveling thing. And if it's not level, it's not happy. You can see the numbers jumping around there because it's on level. Whenever I shift it, it's confused about the weight. So this is a pretty precise one. I have one at home we bought for cooking that was like, I don't know, 10 bucks at Walmart. So I don't want you to go out and buy one, but ask around to some friends if you don't have a scale, because it would be nice, hey, to have some kind of scale to measure stuff. Now liquid stuff, most people have a measuring cup, and measuring cups will often have cups on one side and maybe milliliters on the other side. So if you don't have a measuring cup, ask around for family and friends in the region, see if you can borrow one. You're gonna need it this week. Maybe you know somebody that's into chemistry and they have something that's like, so this is 500 milliliters, this is half of a liter up to that line right there. I got this jug of water at a store recently, and this jug of water is supposed to be a liter. And then I drew this red line on there. A quart, oh, there we go. A quart is a little less than a liter. Sorry, my virtual background's freaking out. So you can see that red line would be where a quart is compared to where a liter is. All right, so let's see. And then temperature, I forgot my thermometer, but some kind of thermometer would be good. In the video I sent out yesterday, I showed, I got my meat thermometer, I got a candy thermometer. So if you don't have a thermometer for measuring temperatures of things, see if you can borrow one from somebody. If you live in Pendleton, then you can track me down and borrow one from me. I have lots of digital thermometers. I'd be glad to loan one out. Why are you going to need this? Because we're going to get used to the metric measuring system. So a little bit more on that. Back, here, here. So again, metric. So that's what we're going to be focusing on this week. Metric. If you're not that familiar with metric, then this week you're going to get familiar with metric. So I want you to know a little about meters and centimeters and millimeters. For mass, I want you to know a little bit about grams and kilograms. For liquid, I want you to know a little bit about what is a liter, what is a milliliter, what does it feel like? And then how is Celsius different from Fahrenheit? We're used to Fahrenheit. I'm asking you to try to start getting used to Celsius. And we have all these conversions that we do, which people have trouble with here and there. And you can get better at those. But the bottom line is, why do we need conversions if we're used to a measurement system? So what does it mean to get used to a measurement system? Well, it means to use it. So for example, I'm gonna stop the share again. I have a foot, and my foot here is pretty close to 1 foot in length. See that ruler almost perfectly fits my foot there. So in most shoes, if I walk heel to toe, I'm measuring feet, literally and figuratively. When I stand up, I'm gonna tilt my camera a little bit. Yes, I am wearing pants today. So when I stand up, the top of my belt here is almost exactly a meter off the floor below in flat shoes. So I know about a meter on me. So it'd be nice if you could find a measuring device that has centimeters or meters on it so you can figure out some part of you that's a meter. My little fingernail here, across the nail part on my little finger, is almost exactly 1 centimeter. Almost exactly 1 centimeter. All right, let's go back, screen share. So a couple things about a meter as far as length goes. Length, meters. So the metric system's all broken up by tens, and perhaps you already know this. So let's make believe that right there is 1 meter long. Usually M is the abbreviation for meter. Centimeters, the next smallest unit from meters, and that would be 100 centimeters. And the C for centi literally means 1/100th. So 100 centimeters, the centi is 100th of a meter. So centi literally means 1/100th. So when I write out, say 1 centimeter, I can replace the centi with 100th. So that would be 1/100th of a meter. Right? More simply, 1/100th of a meter. And usually with metric, we don't worry about using fractions because we have a decimal system that means the same thing, right? Tenths, hundredths. So this would be 1/100th of a meter. And then a centimeter, if we were to zoom in on one, so let's say here's a centimeter right there, 1 centimeter, and then we zoom in on that 1 centimeter, then we would find it's broken up into little pieces. And inside here are 10 millimeters. And a milli is 1,000th, literally means 1,000th of a meter. So milli literally means, oops, ends there, sorry, 1,000th. So the metric system is not really that complicated. It's just a matter of getting used to the different prefixes. We could also blow a meter up and go bigger. And if I were to collect 1,000 of those meters, those things that are the distance from the floor to my belt level, the top of my hip, 1,000 is a kilo. So 1,000, kilo means 1,000. So that would be 1 kilometer, usually abbreviated 1 km. And it doesn't matter whether I'm talking about meters or grams or liters. Centi still means 100th, milli still means 1,000th, kilo means 1,000, not 1,000th, 1,000. So they're multipliers. Some of them make things smaller, some of them make things bigger. So one thing about knowing metric is just to realize centi is 100th of whatever we're talking about. Kilo is 1,000 times whatever we're talking about. All right, next, here we go. I'm gonna jump all the way up to temperature. To get used to temperature, there's a few things you probably ought to know about temperature to relate Fahrenheit to Celsius. So Celsius is a much simpler scheme than Fahrenheit. So Fahrenheit, we talk about freezing. So at sea level, water freezes at 32 degrees Fahrenheit. That would be 0 degrees Celsius. So that's an important thing to know. And then boiling is 212 degrees Fahrenheit. A lot of people know that and a lot of people don't, but it's a much easier number in Celsius. It's 100 degrees in Celsius. Based on just those two, you can come up with a relation, a formula to convert Fahrenheit to Celsius. I'm going to write it down. I'm not really going to use it though. You can find the Celsius temperature by taking 9/5. Oh no, I got that backwards. Find the Fahrenheit temperature by taking 9/5 of the Celsius temperature and adding on that 32 that goes with 0 degrees Celsius. So there's one version of the conversion formula. But what's better to know is 0 degrees is about 32, and 100 degrees Celsius is about 212, so freezing and boiling. Kind of in between these two, some other nice things to know are, say, room temperature and body temperature. So body temperature we believe to be about 98.6. I think on average lately it's lower than that for most people. In Celsius, that ends up being 37 degrees. Room temperature, we like to be about 70 degrees-ish, 70-ish, let's say, and that would be about 22 degrees in Celsius. We're going to do some experiments later where we try to guess the temperature of some water, and then we're going to find a thermometer to measure it. So again, I want you to find a thermometer. If you have trouble finding one, let me know. I'll Let's see if I can help you do that. All right, let's see what else. A little bit about mass and weight. So mass is basically how much stuff is in something. That's just stuff. Weight is a little bit different. This weight is stuff and gravity together. So for example, my mass is, oh gosh, I haven't weighed myself lately. I'm gonna have to make a guess at this. Let's see. That sounds about right. So I am about 70 kilograms of mass. So that's my mass. It doesn't matter whether I'm on Earth or the moon or Mars. I'm going to have exactly the same mass, okay? Well, provided I don't like lose weight or something, or gain it. So let's just suppose my mass is fixed. That's my mass. Gravity weight is different. My mass feels heavier on Earth than it would on the moon. On the moon, I'd be lighter, so I could jump farther given my 7 kilograms. And kilograms measures mass, not weight. So again, my mass is going to be the same on the Earth, the moon, or Mars. My weight will not. Those will differ. So because of gravity, right, I'll feel lighter on the moon or Mars. And it's because, there we go. It's because mass attracts each other. And so the mass of the Earth is pulling on me. I'm pulling on the Earth, but I'm so much smaller the Earth doesn't notice it. On Mars, it's much smaller than Earth, so there's less stuff to pull on me, so I won't feel that pull as much. But I'm still 70 kilograms. But I will feel different because of the way gravity pulls on things. And pounds is a measure of stuff and gravity, which is weight. The equivalent thing in metric would be called newtons. So one version of weight in metric is called a newton. So the newtons I have on Earth is going to be different than the newtons I have on Mars or the moon, even though I'm 70 kilograms on either of those 3 places. But we do use pounds and kilograms interchangeably, but they're really different kinds of units. That calculation wouldn't work on the moon or on Mars. That's a whole different idea there. And generally the relationship between the inappropriate relationship between kilograms and pounds is that 1 pound is approximately 2.2 kilograms. Again, they're not equivalent measurements because pounds takes into consideration gravity, mass, kilograms does not. But we kind of talk about them interchangeably, so we're just going to go for it here on Earth. This is kind of the standard thing. And it's not this that I'm concerned about, right? This is a minor thing because the internet is at everybody's fingertips. I know lots of elementary school kids that have cell phones, unfortunately, and on their cell phone, they can just go to any search engine, Google, and say pounds to kilogram. Pounds to, look at right there, someone's waiting for me to make that calculation. And, oops, did I do that backwards? Oh shit, I have it backwards. It's 1 kilogram is 2.2 pounds. Eek, Gary, so naughty. Scratch this. 1 kilogram is 2.2 pounds. Backwards. And we have the internet, huh? So conversion isn't a big deal anymore, right? We have calculators that do it automatically that people carry around with them everywhere they go. So it's not a big issue. So what we just need to do is get used to this. Find something that has a certain weight. So I'm going to turn off the screen share a second to talk about this. So I have some things here, and put it down for a second here. So things. How much does a marble weigh? How many grams is a marble? How many grams is a little paperclip versus a bigger paperclip? How many grams is one M&M? Now you can go buy an M&M package at the store and it will say how many grams are in there. You can go in there and count all the M&Ms and then just divide to estimate the mass of one of these. Or maybe somebody you know has a scale that might be able to measure that. Okay. So we're going to have to play around with that. Back to share for a minute. All right, so there's a few homework problems about just comparing units. They're not that complicated. Conversions can be done on a computer, pretty easy. Not a big deal. It's not about conversions anymore. So this week, you want to read section 11.1, talks about different measurement units. And then our goal this week is to do the mini metric Olympics. And I sent out a video of me performing the metric Olympics. So before you do that, you should do a few things. Be good to read the chapter first. Then you should do the metric me assignment. So the metric me assignment is where you're going to go out and make some measurements about yourself. How tall are you in centimeters or meters? Now that means, now what I'd like you to do is not measure in feet and inches and convert. I want you to find something that measures metric, right? Maybe you make a mark on the wall behind you and then you use a ruler with centimeters to measure it, right? I want you to measure in centimeters. Forget about inches and feet. Throw those away. We're not going to play with those anymore. If your hand is stretched out, what's the distance from your thumb to your little finger, right? If you're not sure what I mean by that, stretch my hand out here, right? Let's switch the view so it's me. There we go. Come on, zoom to 8, please. There you go. So what's the distance from the edge of my thumb to the edge of my pinky there when I measure across? That would be my hand span. Another interesting thing is, what's your arm span? Spread your arms out, wingspan, fingertip to fingertip. How wide are you? A lot of people are pretty close to their height on average. Some people have longer arms, shorter arms, so it's a little variability. Back to share screen here. So ask about your wingspan here. What's the width of your thumb in centimeters or millimeters? When you walk, how long is your pace? So the length of a stride from one heel to the other. So take 10 steps, measure the distance, divide by 10 to get your average stride. What's your weight in kilograms? It's really mass. Sorry, I lied there. Can you find some way using your body to estimate a meter or a centimeter? So some people will hold out their hand, their arm, and they'll say, from my fingertip over to here is a meter, over to there, wherever on you a meter is. Some people, it's when they stand up, they can find a place. This part of their hip, this part of their rib, this part of their hip is a meter. Okay? So I want you to find some centimeter measurer to check that out. So the point here is just to get used to using the metric system. And then just some side notes for yourself. When does water freeze? What is room temperature? What is body temperature in Celsius? When does water boil? At what temperature? So this is the starting point for the assignment. So you're going to measure this stuff. These things I kind of gave you. You can look them up. Next thing you're going to do is you're going to do a scavenger hunt. So the scavenger hunt is what I was talking about earlier. I need you to find some things to play with and to measure with. So some kind of ruler or tape measure that has centimeters on it. Some kind of measuring cup that has milliliters on it. Some kind of scale that can measure grams. And I bet, like, if you checked with 5 friends, one of them would have something. Or you checked with your neighbors. Somebody in the neighborhood will have something that will measure grams, for example. And somebody will have a thermometer that'll have Celsius and Fahrenheit if you don't. If you're having trouble finding any of these, I'll see if I can help you figure that out. And then we need some toys to play with to do the metric Olympics. And so I list some supplies here. And then I want you to do some warm-up stuff. Okay, so I mentioned, I showed how long my shoe was a foot long, and when I look at my ruler is also just over 30 centimeters. So that means my foot must be about 30 centimeters long. Measure some stuff and make a note of it. And I'd like you to report back to me on this with the list of tools that you were able to find, a list of supplies like what I listed up here or something similar, and then measure a few things and report back to me on them. And the first couple things we measure because we're not used to them. And then after that, what I'd like you to do is guess at some stuff. Like, for example, right now I am looking at my fake whiteboard. I'll show you. Here's my digital whiteboard here. I'm wondering how many centimeters is that top to bottom? Well, it looks shorter than my foot, and my foot was 30 centimeters. So I'm going to guess this is 25 centimeters. And then measure it with my metric measurer here and look. Ooh, I did pretty good. It's 26 centimeters. Kind of hard to see that there in this camera. So estimate, measure to confirm your estimates, just to play around. And then after you've done that stuff, so after you've done the reading, after you've done the metric me, after you've done the metric scavenger hunt and then made some estimates, here I have some things you could estimate, but you could come up with your own things to measure. And again, think about length, think about volume, like milliliters, think about temperature, okay? Like if you like tea or coffee in the morning, how hot is it? If you like a bowl of oatmeal, how hot is your oatmeal? Maybe you like a cold drink from Dutch Bros. How cold is that cold drink with ice in it? Is it really freezing? I don't think so, but it's got ice in it. The ice was frozen, but it's melting. So just think about things that you can estimate in these different areas that we're working on here. Once you've done all that and played around, then you're ready for the metric Olympics. Now, I suppose I should put that video on the top, but I sent out an announcement yesterday. Hopefully you saw it. And in the announcement, I have a video of me out in my backyard doing the metric Olympics. So I kind of describe the scavenger hunt stuff that you got to collect that I've just talked about, and then I go and do each task in the metric Olympics. And then at the end, once everyone's done it, we'll see who has the best metric Olympic score, and then prizes will be delivered out from there. So that's about all we're doing this week. Measurements, basic measurements. We'll get into area and other more complicated volumes later, but for now it's length, it's mass, it's liquid volume, and a little bit of temperature are what we're playing with. And the homework has some problems related to that and the reading. So that's it for now. We're going to check back in on this next class.